Yeah. Hey everyone. So yeah, thank you for coming to our talks today. Yeah, I'll be talking about the USD survival guide. What is the USD survival guide? So first up, like if you have a laptop, you can feel free to scan the code, or also like just visit that link down there. Like wanna scroll through the site. So basically, the USD survival guide is kind of like a onboarding guide. Yeah, from more of a, let's say, pipeline perspective. Yeah, so again, like during the talk, we're going to look at different aspects of it. If you have questions at the end, feel free to look through it on the side, and then we can discuss those in the Q&A section. So I'll dive right in. Why is there another guide? We already have the cookbook, we have all the NVIDIA docs, we have the Remedy Entertainment Guide. There's a lot of learning material out there already. Why did we need another guide? The niche this guide is trying to fill is just be an onboarding guide for more the pipeline and software developer side. And my goal was to kind of create something that is more suited for, let's say, smaller studios, because they often don't have the development resources to kind of get going with USD, because it is kind of a big topic. So the goal of this guide was to be as practical as possible, provide as many code examples as possible, and kind of provide you the bare minimum package. Kind of get started. Does that mean the guide is the ultimate guide? No, of course not. Please look at all the resources. There's a ton of other great stuff. A lot of new stuff has also been presented at SIGGRAPH so far. So by no means, is this a single source of truth or something? So that was kind of the aim behind it. Again, from what point do we come from, or this is kind of the knowledge that we've gathered at Rise. We've been using it for 2-3 years now, USD. So this is kind of what we don't cover so far is the, let's say, more production part of it. It's more about kind of nailing the basics and understanding USD. And I really kind of wanted to kind of boil down the most important, summarize the most important parts, so that onboarding new people, is easier. What is this guide not? Again, it just focuses on what is kind of USD and the concepts behind it from a developer perspective. It is not a high-level guide, unlike some other resources out there. In general, again, everything we show in this presentation, all HIP files, all code samples you can find on the website. The guide is structured, we always have a table of contents on all sides, kind of short summary in a nutshell section. So if you just browse around the guide, you'll find the most important snippets, and what should I actually use it for? Because often, a lot of resources out there explain a lot, but you don't really kind of make the connection to what you actually use it in your day-to-day life. And we also have these blurbs, kind of as you can see there, which warn you important gotchas, pitfalls, and stuff like that. So here's just an example how it looks, for example, for composition. But what will we look at today? Again, this, I don't know how many pages there are. I think it's at least 40 or something, with a lot of content and some filler summary pages. But to kind of keep it short, or trying to keep it short, we'll go into a bit of the overtime in this presentation. We'll focus more on a short overview of the basic building blocks, what you'll use the most when you're interacting with Python, with USD. And then we'll do a very heavy look at what you can optimize in Houdini and what the common pitfalls are. So yeah, what are the basic building blocks of USD? So USD is a hierarchy-based cache format, or actually, let's step one back. Let's take one step back. So before we start, USD is kind of very vocabulary heavy. There's like a lot of terms. The guide tries to stay away from them as far as possible, or we also kind of try to replace it with Houdini terminology here and there. Would we recommend you learn the terminology? Yes. On the developer side, definitely do. On the artist side, you can try to kind of obscure it and try to keep it away. Again, the guide tries to kind of avoid it where possible or use more VFX industry terms. So yeah, how do we get started if we want to do some coding with USD? So USD is kind of divided in two different levels. There's the USD API and the lower level SDF and PCP API. When you start off, or most tutorials kind of focus on the USD high level one, we actually kind of recommend going into the lower one as fast as possible. Why? So like, the main uses of the high level one is you kind of get all your getter setters, nice classes. Like, it's definitely more convenient, and the high level is always used for reading data because it views the kind of composed state of all your layers. So it always operates on the stage level. The low level API always operates on individual layers. So what you'll be using the low-level API for is creating, copying, moving data. Basically anything that is performance critical is always lower-level API. So like the common practice, especially with Houdini, because it's like node-based, what's really cool what you can do is just query another stage and then use the high-level API for that, and then just do all the writing in a low-level API, like via the SDF API. There are also other modules. We'll not take a look at them. They're mentioned in the guide. There's like a graphics foundation module with all it's like basic math module. There's plugin modules, like basically anything else the whole USD kind of ecosystem delivers. But yeah, these are kind of the main two entry points you'll always be looking at. Since USD is a hierarchy-based format, one of kind of the obvious things is working with paths. So what does kind of USD, how do you interact with paths? So there's the SDF path class. This is kind of your go-to thing. Many USD functions also just allow you to pass in a string. We would recommend always just using the path class because it's just might be a bit more overhead when you get started. USD, it's not only your prim path, it's also like encoding attributes, variants, and stuff like that. And it will make your life a whole lot easier down the line if you just use it from the get-go. That's why we would recommend starting out with that. Again, as you can see, it can encode prim paths, attributes, so properties are attributes and relationships, and also variants. If you've been to other USD talks so far, it will also encode some other stuff. So again, just use this instead of just passing in strings where possible as a best practice. This is how we store our path. Then how do we actually store data at our path? So we have our prims, and these store properties, and properties is just a base class for attributes and relationships. So attributes is actually like where all your data is kind of stored. So like points, normals, stuff like that, like anything geometry related. And relationships are just are SDF paths from pointing from one part in the hierarchy to another one. We have the same thing on the lower level API. So again, like all the what was important when kind of designing the guide is that all examples always show higher and lower level. Because again, you should use the lower level as soon as you write stuff just to make stuff fast. That's the basic class inheritance structure right there. basically the higher level API, like again, it just offers a lot of like getters and setters, nice wrappers to kind of access your attributes. Like you don't have to guess the attribute name and whatnot, but you can also just always just get an attribute by name from any of your prims. There are also special prims which are called prim vars. These get exported to your renderer, so anything you want to see on the renderer side, you have to just prefix it with prim vars. What's the name? Colon. And then also, if the same thing as in Houdini, like when we have detail attributes, remember like mantra related workflows. As soon as you have detail, like Houdini level detail attributes, they get exported to your geo. So yeah, prim vars are also kind of the mechanism to set render settings or like display color override on your geometry. So the only difference between normal attribute and a prim var is the syntax, that it starts out with the prim vars namespace. Like syntax wise or API wise. Of course, you can again use like the higher level API, use the primvar class, but you can also just access it all that way. Just to compare again, like the high level, low level. Again, with high level, you get getter setters, and then low level is you set a lot of stuff directly. USD kind of ships with some, let's say, core metadata. This is kind of accessed differently on high level, but low level, high level. But yeah, we'll take a look at that in a second. So again, attributes is kind of where all your data is stored. And here's just a mapping table from Houdini name to USD name. And yeah, I covered the rest already. In general, what's really cool about USD is that like from the Python side of things, like we can, for array data types, so like your points or normals or whatever, we can just access it via NumPy, or like it uses the buffer protocol. So you can also just use like normal, like Python arrays, and that way you can actually edit arrays very efficiently, even with Python. So you don't need to dive into C++. Like you can get a lot, like we'll show a lot of Houdini examples, and can do a lot of stuff within Python, which is really, really cool. And again, just the examples, it's really easy to map back and forth between that stuff. And as also mentioned earlier, like the USD ships with a huge like math module where you have like all the matrix classes and all the like usual good stuff. Same as in Houdini or also other DCCs. USD also differentiates between you don't just have like vector or float arrays. You also have like a role associated with it, because we need to transform different data in different ways. Like we need to transform UVs or a color attribute differently than points or normals. So again, so far we kind of have our paths, and at our paths we have prims and properties, which are attributes or relationships. These kind of store all our data. And then we have schemas. So what are schemas? If we compare to like object-oriented programming, schemas are just they kind of define the base set of attributes a prim has. So you can, there's type schemas, which are like basically every prim in your hierarchy should have a type schema, which is it a mesh, is it a light, is it a transform, whatnot. And then additionally, you can like inherit from applied schemas. So you should always have a type schema. You can also not have one, but that's kind of how it's set up, and you can kind of think of as a prim as kind of an instance of like how it's written here, like these base classes. So schemas use these mechanism of providing like fallback data. So just as again, like in object-oriented programming, you inherit from it, and that's how you get like all the basic data. Yeah, here's just code example how you can set stuff. I know the first part is a bit dry, but yeah, we'll look at some Houdini examples in just a second. I just kind of laying out the basics here. So again, we have different type of schemas and just how you apply them. USD, again, like these are kind of the schemas you'll interact with the most. So basically, API-wise, you just give it your Prim, and then you get all the getters and setters and like extra methods to manipulating the data on the Prim. That is like relevant to schemas. Just a list of the most used ones. There is another building block, which is metadata, which is kind of like the smallest element in USD, you could kind of say. What is managed metadata? Like what you'll most interact with is like setting asset info or custom data. So metadata is basically again, metadata, just data attached to your Prim or properties or layers. So like here's the like class inheritance. Like all the USD based types, or like the kind of ship of USD. So there's a SDF value type names, and then if you go into the API, like I think it can store pretty much anything. Metadata follows a bit of different rules how data is composed. There's some stuff to watch. We also go to like there's some cool stuff you can do with metadata. Like in the guide, we cover that way more. But yeah, we're not looking at that today. Metadata, the most you'll be interacting with it is to set asset info, custom data, or edit composition arc. So anything composition related is stored via metadata. In general, also metadata is a lot faster to access. So if you, a lot of like pipeline wise, what you're basically at the end of the day, what you're always doing is just traversing your hierarchy and searching for stuff and setting attributes. Like what you'll end up doing is kind of using metadata to pre-filter a lot of stuff. And again, USD kind of has a core metadata set. Let's see, did I cover that here? So some stuff in USD is also just, again, more metadata, and that is often used to pre-filter stuff because it's fast to look up. If you want to add custom metadata beside the asset info custom data, it's really easy. It's just a JSON file. You put it, point to it via an environment variable, and then you can also add custom fields. So if you need to customize it studio-wise, it's very easy to do. Like the only standard that USD currently kind of defines is passing in the asset info, like providing the asset info, and that has some predefined keys which you kind of adhere to and like dump standardized info. So this is kind of where we write our data. How is our data actually stored? So USD stores everything in layers, and then if you kind of think of USD in terms of like view model controller or like view model approach, your stages are kind of the view and layers are the model. So at the end of the day, layers are what gets written to disk and what gets loaded and actually do all the data storing. Stages are just what like view give you access to your layers. So anything in the higher level API always just goes through the stage and then redirects that edit to the layer. How does it redirect it? There's a thing called like edit target, and that targets a layer or also something specific within your layer. That's just that's what the edit target word means. If you run into that. How are layers stored? So it's just stored by a singleton pattern. So each layer is only there once in memory, which can be a bit confusing. So for example, in Houdini, if you have two nodes and then you can just, it's a bit small, basically, ignore the code. Basically, we just copy the layer content from one layer into another. So now if I look at different nodes, like I'll let it play again, as soon as we activate the node, yeah, you'll see that both nodes have now the same content. So that can be a bit confusing. Will we ever use this in production? No, but yeah, just remember layers are only opened once in memory, and we can access all layers that are open in the current session. Yeah, and also just, again, layers have identifiers. These get passed through the asset resolver, but that is in a second. But yeah, there's also the concept of anonymous layers and non-anonymous layers. The only difference is that, yeah, non-anonymous layers don't start with anon. And if you want to make an anonymous layer a standard layer, you just give it a URI or file path, and that's it. And then, yeah, again, stages are the view on different layers. Stages also always create a session layer, which just contains all your temp edits or like viewport overrides. So in Houdini, if we look at screenshot for that, like typically just, or like USD view, typically you just store any like viewport overrides. Like Houdini does this all for you, but typically we just store like viewport overrides and stuff we don't want to save to disk in there. Yeah, another thing about layers in general, so like the USD binary format is very, very efficient. When you open files, it only looks into the file to kind of get the hierarchy or specifically what you ask for. So you can actually like traverse, I don't know, like we had the case, like the total data was like, I don't know, like 1.5 terabytes of file or something, but you can like traverse it in like, I don't know, a couple seconds or like 30 seconds, because it only really looks into what it needs to read and when you actually ask for the data. So yeah, it's very, very cool file format, USD. So yeah, there store your data, and stages are the views. So again, here's like a screenshot. You have the session layer. Again, Houdini does this all kind of for you. Yeah, if you see that, and then we have like the root layer, and on that root layer we link other layers. Very short thing. How is the animation stored in USD? Very simple. It's just a frame and value kind of pair. I'm gonna start going a bit faster. Yeah, kind of nothing fancy there. When we just set animation, it's literally just set frame and then value. Yeah, and then another thing is loading mechanisms. So again, USD is kind of made to aggregate data. We always kind of want to pre-filter down as much as needed before loading it. Again, since USD lazy kind of loads all the data, you kind of only need to pre-filter if you're rendering. Like you can get away with a lot. Like if you just look up files with Python, for example, you can get away with just doing it, like not using these filtering mechanisms, because it just loads what it kind of needs to. But yeah, user-wise, like these are kind of the mechanisms we have. Again, I'll speed up a bit. Yeah. And traversing data is, again, on our stage level, the most common thing is we look through our hierarchies, look for our data we need to adjust. And yeah, USD is very convenient. You just get an iterator, iterate through your data. Again, you should pre-filter by core data as much as possible. Core data are what schema, like base types you have. You can just say is A, it's the same thing as is instance in Python. And these checks are very fast. The same actually applies also to LOP selection rules, which is Houdini's kind of syntax on top on the whole thing. We'll also show it later. Again, like filter on core metadata as far as you can, which is schemas, specifiers, activation, kind, stuff like that, and then try to filter down by attributes if you can't detect your hierarchy other way. Other way, it's very straightforward. You just get an iterator and then, yeah, traverses through your hierarchy. Layer traversing is a tiny bit different. You pass in a function, let's call it a kernel kind of function, because it just runs through every path in your layer. It runs through every path, so not only prim path, anything that can be encoded by the SDF path as we saw earlier, so it's also attributes and variants and stuff like that. Kind of how does USD work kind of behind the scenes? It's a whole kind of plugin system, individual components like render delegates, asset resolver kinds, schemas. It's basically just plugin JSON files, and they point to your plugins and they get loaded. So here's kind of the base set you need if you want to get started in production. You could define custom kinds. Kinds are basically, again, just data you can attach to your prims to. It's core data, so it's used in a bunch of stuff. So like few port selections, or you can limit it, or again when traversing. So we recommend creating own kinds because the base kinds are base. You should create your own. It's that simple as creating your own JSON file and just creating custom names. For schemas, you also don't have to compile stuff. So if you want to create fallback properties, you can also just do that all with, again, it's just a JSON file that links to a USD file, and then you don't get the getters and setters with Python, but you get the whole like schema mechanism. So we all have like those fallback properties anywhere where you attach the schema, and same for metadata. It's also just a JSON file. So if you really want to like boil it down from a coding perspective, what you need to do, like the only thing you need to compile is kind of the asset resolver plugin, which can be an issue for smaller studios because they don't have the C++ developer resources. More about that in a second. So again, what is the asset resolver even? So basically USD encodes, if you look for USD files or inspect them in Houdini, anything that has the at blah, 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 like URI at or asset identifier syntax, that gets piped through this magical black box called the asset resolver, and then that outputs a final path. It uses the asset resolver context, which is just an object that carries sidecar info. That helps you kind of resolve your path. So instead of just storing strings, USD has the concept of asset paths, and they get resolved. So it's kind of your mechanism of redirecting paths to where the actual kind of data is. Again, since for smaller studios this is often not feasible to hire someone, we have multiple asset resolver implementations. So currently there's a file-based one, which is, you can use for production. Again, you can also do this with like URI, HTTP, or custom URI syntaxes. But we provide a file resolver. Also a Python resolver. Should you use that in production? No, because Python has like the global interpreter lock, so it won't multi-thread well, but it's good for debugging. So the idea was kind of you can do all the R&D there yourself, and then hire a freelancer or something for a day, and then like he implements it, because that was kind of the idea behind that. We'll also add another one, which is kind of a hybrid, which does all the lookups in Python first, and then caches the result. So you kind of get the C++ speed, but do the Python stuff. So that took over already. So did we forget something? A little thing called composition, which we'll not cover today, or let's say after the talk. If you guys want to talk outside, you can look into that. But again, the guide really breaks down. We can scroll through the site at the end. So we have a lot of code examples, also Pixar examples. We also rebuilt them all in Houdini. A lot of really cool stuff you can learn there. So again, kind of pre-flight checklist, what you should do before USD. For developer side, I would say teach your developers the vocabulary, so you kind of have to speak the same language. So the language barrier isn't there. Plugin wise, kinds and schemas, it's just JSON files. It's doable. Asset resolver kind of got you covered there. What you should really nail down, I would say, what we learned afterwards is data I/O, which we'll really focus on in the next few minutes. Really make it simple for your artists, like don't kind of shock them with too much new stuff. So again, with USD, you kind of have to be a bit more aware what kind of, let's say, data you export. So are you like exporting instances? Are you exporting skeletons? Are you exporting deforming meshes? Artists should, I would say, like a core thing that pipeline should always handle is data I/O. So just make it as convenient as possible for artists to export stuff. So we recommend kind of really building workflows for each individual type so that they don't have to worry about what to do. Other big thing is, of course, USD composition. Yeah, ton of material out there. We cover in the guide so far kind of the basics. Again, also in Houdini, really broken down with all the Houdini nodes, and then also Python nodes, how you can do it fast with larger hierarchies, so it's like scales well. Yeah, we'll be adding more of that in the future in the guide. And otherwise, yeah, kind of make sure your production tracking system handles stuff like yeah, how you track different layers and dependencies. What's written there. Last thing with the basic building stuff, yeah, again, USD is very convenient when like we query a lot of data. It's we'll take a look how we can use that in Houdini in a second. So it's very easy to query bounding box data, literally just xform cache and then get the bounding box or like the transform. Same thing for bounding boxes. USD is very, very convenient. Same for attributes. Same for inherited prim bars. It makes us, yeah, it's very easy to just get data. Yeah, no, skip that part for now. So yeah, let's actually look at Solaris. So in Solaris, we have a lot of nodes. I would say there are a lot of user-facing nodes. Again, this because we're trying to like show more the pipeline side of things. Yeah, the nodes you'll see here are kind of what you'll be using as pipeline. And if you kind of want to go the extreme route, this is kind of all you need in Solaris, pipeline perspective-wise. If you really kind of want to push it and optimize the shit out of it. So yeah, it's pretty much your Python node and the nodes that pull data from other networks and how you merge data or handle time dependencies. Yeah, these are like the nodes you'll be using 99% of the time. Again, USD is its own file format, so like, yeah, you should not tell your artists that everything is going to be 10 times faster. You do have, yeah, different, like you need to convert from and to, like it's not going to have the speed of BGO. You should also like communicate upfront, because again, USD through its whole like layering mechanism, you're going to have you're going to see other departments work, and yeah, this kind of comes with a communication overhead, so you should kind of, basically, if you switch to USD pipeline, really prep for it beforehand, which is kind of, yeah, what's written here. So we really like recommend doing that upfront in terms of like documentation, really like break down all the workflows, set people aside who are like, yeah, people can turn to for questions and stuff like that. But yeah, other than that, we're good to go at that point. We're kind of going to focus on data I/O now. So in general, again, with hierarchy-based formats, Alembic had this too. You always kind of have to find the balance between generating huge hierarchies and no hierarchies at all. Like a good viewpoint, I would say, is like that the perspective of like a rendering lighting artist, because they at the end of the day need to like filter stuff and assign different materials or hide stuff. So what you should not do is create a prim for every little thing. Instead, you should, yeah, really kind of balance it out. On the other hand, you should also not create a prim with 50 million points and stuff like that, because it's just gonna like cache or however you set it up is just gonna get heavy. So it's like a balance between two. So here's kind of like, yeah, checklist or when you should start separating stuff and whatnot. How do we work in SOPs? It's pretty straightforward. We just define an attribute which defines the prim path, and then that stuff gets imported. One important thing to note, like there's a relative prim path and an absolute. So anything that starts with dot or without a slash, yeah, that's relative, and relative gets imported to the prefix path you put on your SOP import node. Or if you use for volumes and point instances, it gets imported relative to these special attributes, Houdini ships. So that's just something aware to be with the path. Yeah, this is, I don't know, boring video, way too small. So yeah, we'll skip it for now. But yeah, just again, in the wiki, it's all in detail, and we go over individual cases. You might think this is kind of a trivial thing, but again, from an artist perspective, you really want to kind of keep it simple for them. So basically, what we would recommend is just give them one attribute, which is just the path, and don't make it overcomplicated. Again, also, when we're working with SOPs, you're always working against a stage. So that, you know, like typically if you worked in a Houdini heavy pipeline, you kind of write out your caches, and kind of a cache is representative for itself. Like it can stand by itself. With USD, it's a bit different. Like you always work against the stage, which has some workflow implications. Yeah, like written here. Actually, I'll skip that for now. Again, with the asset resolver stuff we mentioned earlier, your asset resolver just gets loaded by default if it gets found via the plugin path and environment variable. And in Houdini, you can define the context, so like the additional data that the resolver can use with two ways. So it's just either via configure stage node, and then like your node tree, the leftmost node in your tree, just carries that information through, or globally, yeah, you have this read button here. Yeah, we recommend just using it globally, because then it affects your whole node stream. Yeah, that's what you'll usually be using it for. Time dependencies is kind of a big thing. So again, USD, you saw like the frame value encoding. Traditionally with Houdini, if we load something per frame, we call it Houdini time dependencies. So if you work in SOPs, like your kind of goal is to always get rid of time dependencies, to just make everything fast, and then only have time dependencies where you really need them. With USD, it's a bit different, because yeah, you can just write time samples, then you still have the whole animation range access, but yeah, your node is not time dependent, which is really cool, because that kind of means for our workflows, yeah, just pre-cache as much as possible, or always write full time frame ranges. I think with, what was it, Houdini 19.5, yeah, we have the small dropdown in the top of nodes, and that just always cooks the full range. So basically just use that on every node, then you'll lose the time dependency, and then best case, your USD ROP node, like that's why it's caches, or for rendering, the only thing it has to do is actually cook the active frame. We can do this for stuff we do in our node tree. For geometry imports, we of course can't, because yeah, geometry importing is way too heavy. So for geometry importing, you usually just cache like the current frame with your shutter range. So yeah, you get like deformation, X-form, motion blur. So it's just a cache node, and then yeah, write the time samples. If you can't, like not all Houdini nodes, a lot of them will also get in the future, don't have like this menu up here yet, or most of them have, but yeah, some don't. So if they don't have it, just use a regular cache node. Does the exact same thing, a bit slower, but yeah, the outcome is the exact same thing. Yeah, so I know this so far it's, I guess, kind of been more theory. So actually, let's see how simple it is to do stuff in USD. For example, frustum culling. Because again, we have like access to the full time sample range, we can just do culling for a whole range within one single node and just batch apply it. So we can also like calculate what is in the frustum over the whole range. So yeah, I do like there's faster ways to do it than the left side of the tree, but just like to compare it, I don't know how many seconds it was, like 2 seconds for 100 frames with like 10,000 each instances per frame, and yeah, you can just batch kind of process it in Python. And the code, again, is really simple. Like, just to demonstrate how simple USD makes it for us. We just get the camera, get the frustum, get the bounding box cache, do this whole thing per frame, and then there's literally just a function called intersect, and then you apply the visibility. It's really that straightforward. For instance, it's a bit different. Yeah, but, again, this whole code is included in the repo and website. You could just download it, play around with it. Yeah, let's look at different Houdini data O types. So again, as showed earlier, it's really easy to import this stuff in NumPy. So this is kind of more a proof of concept to just show how easy it is to manipulate data. So here's a like we're not using the SOP import node. Instead, we're just streaming it directly ourselves with Python into USD. It's really kind of that simple. So again, we just have the attributes. We use get, where is it? Like from NumPy, or and then get the attributes, set the attributes. It's a couple of lines of code. One very important thing, you also, like with all geometry or boundable types, you always have to set the extent so that the bounding box cache can do faster lookups. So yeah, this is kind of your minimal set. Just as a fun little prototype, here's a Python wrangle. Again, also included in the examples. We just inject a snippet, store it on an attribute, and then run it. And what is something you could do with that? Just, to play around. For example, you can build a point replicator. Now you can also do this with render procedurals, which is kind of what you should be doing. But yeah, again, this is kind of like proof of concept, what you can do it with. Like we've used this principle, like stuff for just multiplying velocities or p-scales. So there's, you can actually use it for production-related stuff. But yeah, here's how I also show it to actually like do point replication. And I think it was, what was it, like 25,000 to 250,000, and it's still relatively fast if you kind of code it the correct way in NumPy. So like what I want to show with this example is like you don't have to be a huge studio who writes its own like compiled language or something. You can do kind of basic stuff, very specific stuff, and kind of get away with it because USD is very, very flexible. Again, but for like points and deforming geo, just stick to what Houdini gives you. But if you want to play around with this stuff, it's very, very simple to do. Let's look at point instancers. So point instancers are just USD terminology for copy to points. Does somebody notice what could be an issue? Or let's look at it first. So point instancers just store the positions. If you have the copy to points node, you have positions, orientation, scales, and then what you actually want to copy. So USD just encodes it as your arrays and then your prototypes list. So I think I forgot to mention this. Relationships are not animatable. So the only thing that is actually animatable in USD are attributes. So it also means composition arcs and stuff. Time offset's not animatable. You can offset or scale it, but like nonlinear, or animation is only stored on attributes. So what is kind of the issue here we run into? Prototypes are stored as a relationship to other prims. And then we have the proto indices, which just map which index to instance at what point. So what's the issue with this? So in Houdini, we work kind of with the active frame. So if we have our import node and scrub through, like everything looks amazing, great, cool. Let's emulate how it looks if we cache it to disk. So by just adding a cache node, we cache the whole frame range. So as you might have noticed, if I like jump back here again, like this all looks fine, but as soon as we go to the cache node, we should have these cylinder shapes in the middle, and now which we don't. Why don't we? Like, why doesn't it map correctly anymore? Because the prototypes are mapped wrong. So as a practical example of, again, like using NumPy and editing stuff, this is what you have to do for point instancers to basically kind of work if you're writing per frame. And if you want to make the lives of artists easier, is to reorder the points based on what prototypes occur over the time range. So on the LOPs instancer node, this is basically just handled by you always just pass in all your prototypes, and then it maps the index to the prototype. But if you want to kind of give your artists the flexibility of, again, like what we recommend is just really keep it simple and give your artists just one attribute, the path attribute, to handle. They shouldn't really be worrying about, oh, I need to pass in all instances all the time. They should just have the regular workflow of, oh, I can delete stuff, and it should still look the same as over the time range if it's cached versus an active frame. So like a practical example, again, code included, is that you reorder your prototypes based on sidecar attributes you track, and then you just have like the native copy to points workflow kind of going. Okay. Oh. Again, we can really get performance out of stuff. Like these are kind of edge cases. It may seem, or So or not edge cases, but like again, what we recommend for special geometry types to really like write specific kind of export ways for them. So for point instances or RBD, really kind of nail down your workflow, which also means, as with the point example, for example, for point instances, instead of having all the overhead of creating packed prims via copy to points and then SOP importing that, why not just pipe in points, forward those to USD, pipe in your prototypes for those to USD. It's like 20 times faster, and of course you don't have access to the packed prims, but depending on the workflow, you can kind of build around it. Of course, you could say, why should you do this? But in terms of like scalability, or it's something always like worth considering. So another special case, as we mentioned earlier, with like hierarchy size, the thing you should again shouldn't go into millions of X-form prims. So RBD is kind of a really kind of interesting edge case. So what could you do? Like side effects also ships with this RBD destruction node, like a way, and it kind of shows this stuff. In our example, what we do, again, we kind of go back to the mechanism of how can we use SOPs to our advantage to kind of already like pre-process the data, separate it out, and then import only what we need into USD kind of separately, and then layer it back together. So like the RBD destruction node does stuff like this with Python. We basically use SOPs and VEX to our advantage, separate everything, and then make it really, really fast with, by kind of doing it ourselves. Again, with remapping some stuff with a NumPy, but also, just using standard VEX and SOP stuff. So for RBD, we actually like recommend skeletons because they just store the transform and then deform your mesh. And this example, again, I'll just go through it, but it's a whole lot faster if you kind of again use like the best of all worlds or networks, and then you can like really with millions of packed transforms kind of get real-time-ish playback. Can we break it down on detail? Or look at the website. HDAs and SOPs. So again, this is kind of the minimal working set. Now there's this one, let's say Houdini-ish thing you kind of have to pay attention to. So what we recommend, just jump ahead right there. Basically, how Houdini stores the layers is a bit different. You're always kind of editing the topmost layer. And between each node, there's kind of, so that you can like jump through different nodes in your network. Houdini does, like per node kind of creates a backup of the active layer. What does that mean if we create a lot of heavy data? So up here, we just have a Python node which spawns like a huge hierarchy. And then we want to edit something in the same layer because it's the topmost layer. Our edit is going to be really, really slow because it just how Houdini tracks the data. Fix is very simple. You just add a configure layer node, start a new layer, and then everything is real time again. So that's why, like, HDA wise, we're kind of like the default setup. We, I guess it doesn't play. Would kind of recommend is always starting your HDA off with a new layer and ending it with a new layer, because that way you kind of encapsulated the edit. On file write, it all gets flattened out anyway again. Yeah, another thing, merge order also matters. So unlike SOPs, I mean, yeah, SOPs get different point indices, but you kind of, no matter what way you merge it, you kind of get the same result. With SOPs, you kind of have to be more aware in what order you merge stuff. Again, like the name of the game is, isolate your time dependencies, again, with the drop down at top or cache node as far as possible. Again, if you're importing live geo, then you kind of only do it to a certain extent, but basically all your lighting scenes shouldn't have a time dependency, best case. Like if you set them up correctly, and that way you can just export current frame and you still have all the animation data, which is really, really cool. So yeah, we kind of cover that. I was going to insert a joke, but no time. So yeah, again, if you have like these diamond-shaped networks, always just use a layer break. Typically in LOPs, you kind of can build a lot of stuff monolithically or like standalone trees and always merge them in. If as soon as you have this branch set up, always layer break. So we just recommend just create your own HDA and just have two outputs and split the right output with a layer break. Just to make it convenient for artists, because yeah, USD is kind of very forgiving if you just start layering stuff on top of each other. Because the hierarchy will be the same, but yeah, can potentially like load everything double, triple, whatnot, and it kind of starts getting buggy. So that's why you should not do that. And again, merge order matters. If you have the same attributes, so I have two cubes with two transforms. If I switch the inputs, I'm gonna get a different output if they write to the same attribute, which in this case is a transform. So just what we recommend, keep it simple, try to keep it kind of monolithic or isolated node trees and merge them in. It's kind of the way to go, and also keeps things fast. Again, yeah, we didn't touch on composition, but to kind of also show how simple it is, what we recommend, basically prototype everything with Houdini nodes. It's really great to, yeah, just prototype stuff out in Houdini because it's super convenient to set up stuff. And then at some point, just rewrite it in Python because you can batch apply stuff. So yeah, not gonna go into details to wrap it up. But also like with variants, if you've ever created them, what we came back earlier to, like the SDF path encodes variants, and just here as an example, like how simple it is because of like how cool Houdini with being node-based is. You can just access a stage beforehand. You usually like flatten the layer. So basically you have, if you have an HDA, like the typical setup is you have two inputs, the right input, you just flatten that, it's all on one layer. So all the data is on one layer, and then you either just merge it in, or you can actually like copy the content or specific parts of the content from the right input into your left input. And like a really kind of cool typical example of that is like dealing with variants. So yeah, it's really kind of straightforward to batch apply that to large hierarchies. So the code is really simple. Yeah, like it's really just appending the variant selection to the path. Again, it just encodes it with those brackets. So that's why we recommend using SDF path. And then you, like this is just like this is the. So you can either rename it or you can just copy it. It's really that straightforward. So you just have the path, you add what variant name, like variant set name, variant name, and then you just tell it to copy from layer A to layer B, and then you got your variant. And again, with like this node-based approach of, again, just you kind of read stuff. So everything that is like being done with stages from another node, and then you just copy content in with the lower level API. that way you kind of get the benefit of like both worlds of using the high-level API and having everything fast with the low-level API. We'll skip that. Just a fun little tip at the end. So Houdini, basically every node you edit just stores some metadata with the temporary session ID. This gets stripped out as soon as you write to disk. So if you want to jump to a node that made the edit, like that last edited a Prim, you can just store the node ID and then easily retrieve it. And then, for example, we use it to jump from material selections to the material in the material container. So it's just some fun little side info. To summarize, USD can kind of be daunting to switch to. The purpose of this guide is to kind of make it easier, especially for pipeline people, for onboarding. And again, USD is kind of here to stay. Everybody's jumping on the hype train, and we hope that this guide makes it easier. Again, everything we showed is on the website, kind of ready to use with ready Houdini scenes. And then also, again, special thanks to SideFX for having me, for Rise, and having trusted me to co-develop the USD pipeline with the awesome Rise team, and also, various members from the pipeline team for giving me feedback during the creation. And again, also check out other resources because they're great. And we're also hiring, so talk to us. That's, I guess, kind of it. But any questions? Or again, I'll just show the website really briefly. Again, it's all there. You can also self-host it on premise. Just download the GitHub repo. There's just a bat sh file, run it, and you're kind of good to go. And again, we deep dive on a lot of topics.
So first, I will say, one of the great things about this Houdini community that we all love so much is the generosity of people like Luca, who put so much work and time into creating these things. That USD survival guide is going to be a hot one, because best practices in USD implementation is one of the questions that comes up all the time. Questions for Luca? We might have time for one or two. Yes, and yes. Start with here, and then we'll go to you.
Do you have any info on managing variance across complicated assets? Where do you put them, and how do you drive them across the hierarchy?
Any tips, or what was the question?
Any tips or any gotchas, how to manage that so you're not reevaluating the whole hierarchy every time?
What was the last sentence?
So you're not. Say you have a complicated asset with lots of geometry and lots of
how you handle the nestedness.
I want to have variance.
Our approach is kind of really define out from a pipeline perspective, naming conventions, how you if you have nested stuff, because you don't know where stuff is gonna kind of pop in, and just adds a lot of complexity. So just really define beforehand how you want to nest stuff, and then you kind of know what you're dealing with. It's more of a naming convention kind of type.
Thank you.
Thank you for the survival guide and presentation. So my question is regarding traversing the layer using the kernel function. Do you have to specially specify that don't go over the instance proxies or the abstract class frames, or it automatically knows not to go over them?
So with layers, it just traverses into the whole layer. Because with stages you have instances and whatnot, but with layers it just goes through the whole layer content. Okay. So you just pre-filter by, it just looks at everything.
Cool. Okay. Thank you.
Sorry, I'm kind of interested in getting your perspective, because I used to be in the film, but I'm now in the game. Do you see USD also as a viable? I know there's some stuff missing in the USD format, but you see it as a viable production tool, I guess, assembly tool for game production? Or is there anything inherent that would make it like, even in its future integrations, it wouldn't be very good for games?
Not too familiar with like the game engine integrations, but basically, since game engines always like optimize the heck out of geometry, or like they convert to their own formats, like it depends on how, like you're always gonna have that conversion step if you really want to like have performance. I would say so. Yeah, like you're going to have to deal with that kind of. So it is kind of a format to like organize stuff.
Right.
But then at some point you have to optimize it for your output kind of.
Yeah. But as a general format, you see it also because it seems like it's being pushing USD for a lot of production, but it's also usable for
could be like handle everything, whole asset side with it, and then convert it at some point. I mean, yeah, it's difficult, but yeah, as its game engines are it's way more optimization based. So.
Yeah, on the back end. Thank you.
And I'll just say there are some game studios that are heading towards USD, for sure. Oh, mentioning it. Thanks so much, Luca. Amazing stuff. Thank you for putting that USD survival guide together.